Okay, so now example 4. Okay, if you remember the last time we covered up to example 3, and then we said uh, we should go over um, from example 5 to 8, I believe, if I'm not wrong, before we start today. If you have done that, that's fine. If you haven't done that, that's all right as well. We'll try to cover those examples today. So example 4, if you can see the screen, it says the English phrase, go to the store and buy me eggs and bagels or cereal. Okay, now the question says it's kind of ambiguous. And why is that? So now I have to share my screen from my iPad so that I can write stuffs and you can see those. So the thing is, this phrase, buy me eggs and bagels or cereal, could have two different meanings. And let me show how. Okay, I'll stop sharing this one. Okay, now I'm back with my iPad. Okay, to go. So today is 12, is it? Okay, the question says, so that's example 4, buy me eggs and bagels or cereal. Okay, now we could have two different options. Why? Because this and means we have two conditions, okay? That is, buy me eggs, and it could be either bagels or cereal. Okay, that means we're looking for, that's our condition 1, that buy me egg, that's condition 1, okay? And the condition, second condition of it is, along with that, along with the eggs, I need either bagels or cereal. One of these two. Okay? So I definitely need eggs. Along with that, you have to buy me either bagels or cereal. So that's one thing. Okay? Or it could actually mean buy me eggs and cereal, eggs and bagels, my apologies, eggs and bagels or cereal. So combinedly, it could mean one single condition, and the cereal could be the second one. Okay, so it could mean that you either buy me eggs and cereal and bagels, or if you just buy me cereal, that's fine. Either of these two conditions. Okay, now how can we remove this ambiguity? We want to be clear, right? We want to be transparent. We want to use these English phrases in a way so that if I say this to anyone, they should be able to understand. They should be able to crack the code, right? So how can I do that? We can use um, parentheses for it. For this, we can use parentheses to clarify things. Okay, which which condition I'm actually implying here. All right. So for example, if I just remove the colors from here so that it doesn't become too clumsy. Okay. So let's say I actually need eggs and bagels or cereal. That means if you just buy me a cereal, that's fine. Or if you could buy me eggs and bagels, that that works for me as well. So if I am actually looking for that, I can use a parenthesis like this. Okay. So this clearly means I want either this in yellow, okay, or if you could buy just the cereal for me, that works as well. So this way, I can actually clarify things. You know, I can keep things really, really clear. Okay. Or if I'm actually looking for the other option, that means I'm looking for eggs and either of bagels and cereal, then what can I do? I can actually change the order of parentheses. Let me use a different color then. Use this one. Okay. So that means I'm looking for this. That means I definitely want eggs. And with that, you need to buy me either bagels or cereal, one of these two. So you can see using parentheses make things really clear, right? Now, why are we trying to learn this? You'll see this soon after we finish this next one or two examples. Okay, so if you have any question, just hold on tight. I'll give you options once we go after this next couple of examples. Okay, so before going for the next example, we need two definitions. The first one is statements, and the next one is conditionals. If you have the book in front of you, you can see the definition. Okay, so if I say statement, what's the first thing comes into your mind? What do you understand? Okay, so statement in logic is actually giving you an idea that whatever you're saying or whatever you have written can have only two results. It could be either true or false. Okay, that means you are this actually signifies that it could happen or it can't. Okay, it couldn't. That means whenever you're saying something, you are definitely implying that this thing, whatever this is, it's either true or false. Just let me give you one example. So um, let's say I need a vacation, okay, which is on cards after we finish our lecture today, because as you know, on Monday there will be no class. I hope you guys know. If you don't know, uh, that's a brand new information for you guys. But I think that's a good thing to know, because on Monday you'll have an extended uh, weekend, as far as I know, because of the President's Day. There will be no class. Okay, so I need a vacation. So that is a statement. How is that? So this could be either true or false. Can you derive any other results than this from this line, from what I've written here? Can you imagine any different result from this? Because yeah, I need a vacation. This is true, or maybe I'm lying. maybe I don't need, right? You can't really imagine anything else from it, can you? Try to imagine, try to use your intuition. Okay, one more example. Let's say, okay, let's show it mathematically. Let's say 100%. Let's say 100. Don't try to use percent here. So let's say 51. Okay. So if I say 100 is greater than 51, let's say you don't really know what these uh, numbers are. Okay, because not often it could actually be true. Okay, because it can change depending on the facts you are the conditions you are giving on it. Okay, the conditions you have imposed on this. So forget about it. If I write something like this, it could actually mean two things. It could actually be true that whatever your conditions are, this 100 could be bigger than 51, or it could be false. That means no, 51 could be bigger than 100. So that means you can't have any other result than this. It could be either true or false. So we say this is a statement. So this could be a multiple choice question. Not really multiple choice question. It could be a problem with two options. It's still multiple choice, but not traditional multiple choice question like 5 or 6 options and all that. So if I write a question like this, you need to see whether it actually a statement or not. Okay, that's quite obvious. You can actually imagine these things. Okay, and we'll have tons of examples within next couple of days. All right. Okay, what's conditional? Now, conditional means you actually impose conditions on that. Okay. So for example, if I say that if you get, should write it in small letters. If you get 90%, I'll give you an A. Okay. All right. Or I'll give you a B. Okay. Now, what does this mean? I shouldn't write or here. I should write else. Okay. So what does this mean? This means if you somehow manage to get 90% in this course, you'll definitely get an A. Now, what if you don't get it? Okay. So this means you will not get an A. What will you get? You'll get a B. Although we actually have more options than this. This is not really for our course. This is just a statement, okay? Conditional statement, okay? So this means you are having a condition. You have to satisfy a condition. So for getting an A, you have to get 90%. So that's the condition. Unless, or rather, otherwise, you'll get B, okay? So conditional actually gives you more options, more than one precisely, so that you can, if you satisfy one thing, you get one in result. If you can't satisfy, you get something else. And now we'll quickly see one example and then we'll go for questions and answers, okay? So example 5, let's take a look at this. It says, if it's raining, then we'll go to the mall. Otherwise, we'll go for a hike. Okay, now it says if it's rain. So let's say rain. So that's the condition. Can you see that? So everything depends on this thing. everything depends whether it rains or not, right? So if somehow it starts raining, the condition said we'll go to the mall. But if it remains dry and cozy, it doesn't really rain, we prefer to go for a hike. Okay, so if it doesn't rain, we'll go for a hike. So clearly, you can see that this entire result depends on this condition raining. Okay, if it rains, we'll go for uh, shopping in the mall. If it doesn't rain, we can go for a hike. So that's the condition. Can you imagine these things? You have been using this, right? Not probably not in this way, but often when you're chatting with your friends, you talk like this, right? Hey, that if the professor gives you a question like this, you will solve it. Otherwise, I'll solve it, right? Often we talk like this. So that's the conditional. That's still a statement, but that has conditions on it. So we say that's a condition. So now let's take a break of half a minute or so and see if you have any questions. Just go over these two examples and the definitions. And if you have any question, you can unmute yourself and we can chat about that. These are really, really basic things. We'll actually go to more sophisticated problems probably after the uh, weekend. Okay, so on Wednesday. And we will probably have one more example, rather one more homework. Uh, I'll post it during this weekend, and once I post it, I'll definitely let you guys know that I posted a homework, and when it's due, I'll definitely have it in the announcement. So keep an eye on that, and definitely when you log into My Open Math, if a homework is posted, you can actually see under that when it's due, up to when it's available, right? So keep an eye on that, and as I said, I'll definitely make an announcement once I post it. But I'll definitely post one homework during the weekend. Okay, and that will be a really smallish one because we haven't really covered that much content from logic, but uh, probably one or two or three multiple choice questions or something like that. Okay. All right. Any questions from this? Or any questions you can uh, remember from the last lecture or from the examples we have seen so far? All good? Okay, let me give you a problem then, a quick problem. Uh, which one should I give it? Okay, so, okay. All right. So here is a quick one for you guys. I'll give you 30 seconds for it, okay? And you can actually write that in the chat section. You can just write the answer. It will be a single uh, number. I mean, you don't need to show your work. You just need to type your answer in the chat box. Send me privately. Don't write that for everyone. So the question is, if 100 is bigger than X, then X1 will be 100 X, else x2 will be 100. Okay, so if now I'm saying x is 1 or 2, what would be your answer? I'll give you 30 seconds for it. Just write your answer in the chat section. Okay, I can already see the answers are coming. Okay, you said you didn't understand the question. Okay, so I'm actually trying to impose a condition. So I'm saying x is a number, okay? I haven't really given you that. So if 100 is bigger than x, so I'll say you just need to write x1, which is 100 times the number, which is x. If it's not, if 100 is not bigger than x, you need to write x2, which is 100. So my question is, if x is 1 or 2, what would be your answer? Is it x1 or x2? Okay, so I've said x is 1 or 2. So 100 is, if 100 is greater than 1 or 2, is it true? Is it true? Is 100 greater than 102?
No.
No. So I said, if it's not true, my answer is x2 equals 100. Does it make sense? Just try to imagine it, because if you somehow go for a higher mathematical calculation in future, if you do uh, programming like Mathematica, MATLAB, and all that, if you use those, you will have these conditionals. Okay, you need to set up a program like this where the x is not given at the start. You can use different x's. You can try 1 or 2, you can try 99, you can try different numbers and see how it works. Okay, just to um, go for solving a bigger problem. So I'm saying I'll take a number randomly. Okay, let me try to use easier phrases. So what I'm saying here, I'll try to pick up a random number. Okay, I'll pick up it randomly from the whole number world. Okay, I'll just pick up a number. So my question is, I'm telling the computer that whatever number I pick up and give you, if 100 is greater than that, okay, try to understand it. If 100 is greater than that randomly picked number, I'm telling the computer that you need to give me a number which is 100 times that. Okay, 100 times that number. If 100 is not bigger than that randomly picked number, I'm telling the computer that you just need to give me in result 100. You just give me 100, nothing else. I'm just telling the computer what it needs to do. So if I randomly pick 1 or 2, now I'm checking the conditions. 100 is definitely not greater than 1 or 2. So I've already told the computer that if it's not greater than the randomly picked number, you just show me 100. That's it. You just print x2 equals 100 for me. Okay, so the answer would be x2 equals 100. If you're still confused, let's say I have picked up a number 97. Okay, I've just picked up a random number. I've already written this program and given this to the mighty computer I have. Now, finally, I picked up a number which is 97. So the computer now checks that whether 100 is greater than 97, and it can clearly understand yes, that yeah, 100 is greater than 97. Now it will print x1 equals 100 times that number, as I have given this condition, 100 times x is 97 here. So in return, the computer will print this for me. Now, does this make sense? Take your time, okay? You don't need to hurry. You can take your time, take a deep breath, and try to see what's going on here. Is there anyone is still with confusions? We can rediscuss these things, okay? Anyone? Any questions? All good? Yeah, exactly. That's a hypothetical problem. Yeah. And as I said, if you somehow go for mathematical calculation using different programming language, you will use this millions of times, to be honest. During my undergrad, during my master's, and now during my PhD program as well, I have been using this uh, conditionals when I'm writing a program, probably millions of times. Okay, so that's just one example that how it works, right? Okay, let's go to the next example. And meanwhile, if you still feel that you have questions to clarify, we can chat about that. Okay, so don't hesitate. If you think you have questions, you should go for it. So the next example we're looking for, let's say, which one should we go for? Let's try. Okay, let's try example 7. Okay, let me start sharing it for you guys. Start this. Can you see the screen? I hope you do. I hope you do. Okay, yeah. So the question says, I have an expression, okay, that if a1 is greater than 5, then 2 times a1, then separating with a comma, it says 3 times a1. Now, the first thing is we need to understand what this actually means. Then we can solve it, right? Okay, so it's actually written using a mathematical expression. First of all, we need to understand how does it look, or what does it actually mean in English, right? So the condition says if a1 is a number, okay, it's not yet given, okay, it's not yet given. So if you pick up a number a1, and then if you check that it's greater than 5, then you need to tell me what's 2 times a1, whatever a1 is. If it's greater than 5, you just need to see, you just need to eyeball that it's greater than 5 or not. If it's greater than 5, you just need to print 2 times that number for me. Otherwise, that means what does it mean by otherwise? That means the other possible result of it is that randomly picked up number is less than 5, right? It can't be anything else. It could be equal to 5 though. It's not really given here. What happens if it's equal to 5? So we don't need to care about it. So if it's less than 5, that means the second condition says 3 times A1. That means if you pick up a number which is less than 5, you just need to print 3 times that number for me. Can you see that? Can you see the pointer from in my screen? So I'm giving this to the computer, and then after a while, I'll pick up a number and input it to the program, and then the computer will do the rest. Okay, so I've told it that I'll pick up a number. You just need to check if it's greater than 5. You just print me a number which is 2 times that number. Okay, just twice that number, whatever I picked. If it's not greater than 5, okay, you just need to give me 3 times that. So we can actually pick up 5 and see what happens. Okay, let's say my A1 is 5. Can you imagine what will happen? Just try to use your intuition. What if I pick up a number which is equal to 5? Don't look at the solution.
Would you do 3 times A1?
And why?
Because it's equal to, not greater than.
Exactly, very good. So I've already told the computer the only thing you need to check whether it's greater than 5 or not. Okay, right? So if it's not greater than, I've told it just print 3 times that number. So if I pick up 5, 5 is not greater than 5, is it? It's equal to 5, that's all right, but it's not greater than 5. So I've already told the computer, if it's not greater than 5, whatever I picked, just print 3 times that number for me. So what would the computer give me if I pick up 5? What would be the number?
15.
15, very good. Any question from it? Try to understand what's going on. We are starting really, we are on for the new business here, okay? We're up for the tougher problem now. Slowly and slowly you'll see we'll go for more sophisticated problems. So if you have any doubts, this is the right time. Okay, where did you get 15 from? Okay, very good question. So I have told the computer that I'll pick up a number. You just need to check whether it's greater than 5 or not. Okay, so if it's greater than 5, I'll take 2 times that picked up number. Whatever I'll pick up, I'll get 2 times that number. Okay, if it's not greater than 5, I'll pick up, or rather I'll get 3 times that picked up number, whatever I'll pick up. So first of all, if is the condition clear? Is the conditions clear rather? Okay, now I have picked up 5. Let's say I have randomly picked up a number which is 5. Now what's the first thing you need to check? Whether or not it's greater than 5, right? The first thing the computer will check, or if I'm writing it for you, the first thing you need to check that whether this picked up number 5 is greater than 5 or not. Is it greater than 5? Is 5 greater than 5?
No.
No. It's equal to 5, but it's not greater than, it's not more than 5, right? We have precisely said that the picked up number has to be strictly more than 5. It has to be at least somehow, some extent, it needs to be more than 5. It could be just a little teeny tiny portion, but it still needs to be more than 5. But I picked up 5, which is not really greater than 5, which is not more than 5, right? So I've already said if I picked up a number which is not greater than 5, as you can see the pointer on the screen, I'll pick up, or rather I'll get 3 times that picked up number. So what's the picked up number here? It's 5. What's 3 times that? It's 15. Now, does it make sense?
The one thing I'm confused about is which is how you know which equation you use when the condition is false versus true. So like how would you know that if the condition is false you use 3 times a1?
Well, that's given. That's actually given, as you can
Okay.
see.
Okay.
That
So
if
just
that
one
if
is first.
yeah, carry on. Yeah, sorry.
So just whichever one is first in the list is the one you use if the condition is true.
Yeah, exactly. Good
Okay.
point. Good
Thank
point. Yeah, right. Unless otherwise is mentioned, the first one is for if the condition is true. Okay, and the second one is if the condition is not satisfying our given assumptions. Okay, yeah, that's a good point. Yeah. Any other questions? Take your time. Okay, we'll have more complicated problems, but these are really fun things. You know, once you start understanding these things, these are really funny and these are really interesting things. I'm sure you'll have fun when you solve it. Yeah, go for it.
So it's only written like in the parentheses with the commas because it's supposed to be a computer program, correct?
Yeah, we're trying to generalize things. Okay, yeah, even if you write it on paper, it should still mean the same thing. Yeah.
Okay, thank you.
Mhm. Any other questions? Okay, let's quickly go to example 9 before we finish. Okay, so you can see it says a parent might say to the child, if you clean your room and take out the garbage, then you can have ice cream. Okay, you can, if you can clean your room and take out the garbage, and then only then you can have the ice cream. Okay, now what does it mean? How can you have the ice cream? Whether if you if you just clean the room, will you get the ice cream? Or if you just take out the garbage, um, can you have the ice cream? Or
No.
do you need to do both to have the ice cream? You just need to understand it. That's it. Anyone?
You have to do both.
Okay, so when I'm saying or rather writing this using and, that means you need to satisfy both the conditions, right? If I had written with or, that means you needed to satisfy, you are required to satisfy just one of those. But when I'm phrasing it with an and, that means you need to satisfy both the conditions you are given. Okay, so you have two conditions. You need to clean the room and then you need to take out the garbage. Okay, so if you satisfy both this, then uh, your parents will give you the ice cream. Okay, that's the condition. If you somehow do one thing and don't do the other, you will not have the ice cream. So that's what uh, this English phrases emphasize. Okay, I think I've said this a couple of times before, even before we started logic, that these English phrases are really important. You know, so this you need to understand what the statement, what the conditions are, what it's actually trying to say, and then you will be able to get the final result. You can walk in the right direction. Okay. now, what's next? Yeah, so for Monday, I just need to give you heads up for this, that we'll start using notations. Okay, on Monday, you'll see we'll start using notations, different notations. Let me show how. So at page 413, you can see uh, some notations for different expressions. So we want to know these things. What does it mean? And when can we use it? If it's been used, what can we derive? What are the informations you can derive from it? So these symbols are really important. Okay. So let's quickly go over these symbols, and then if we have enough time, we can see one or two more examples. Otherwise, we'll start on Wednesday rather, not Monday. So if a symbol like this is used, let's say uh, that's a V. Uh, it actually is upside down, right? So that does look like a V, but it's facing downwards. So if that symbol is used, we'll say this means and. So often we'll not write A and D and. Instead, we'll use this symbol, and you need to understand why on Wednesday do we not have class on Monday. So as far as I know, if I'm not wrong, if I'm wrong, correct me, that on Monday it's President's Day, and I think we have a holiday on Monday, as far as I know. So I'll cross check it, or if you already know that the class is actually on, you are correct. Okay, yeah, I thought so. I thought we have a vacation on Monday because I have a tutoring job on Monday as well for CASM. They have already sent me the email that we don't need to uh, go for CASM on Monday. It's a holiday. So that's when I actually thought it should be for everyone, not only for CASM. Anyway, yeah. So that's an extended weekend for you guys. That's a good thing. Anyway, so instead of and, we'll use a symbol like this. Instead of or, we'll like a symbol like that, a V that clearly looks like a V. But if I use this in between two conditions, you can clearly imagine that's not a V, because that doesn't really make any sense. So that will mean or. Okay, so that means we'll have two different conditions, and you need to satisfy one of these. Okay, and the next one means negation. That means we don't want to do that. We actually want to do the opposite of that. Okay, we'll see more examples on this on Wednesday, but for now, just try to remember, if I have a symbol like this in front of anything, that means we mean negation. Okay, that means we don't want that. So if I write that like this, as you can see the pointer, negation A, that means not A. Okay, we don't really want A. This negation means not that. So if I have that in front of anything, that means we don't want that, not that one particularly. Okay, these are kind of ambiguous, but once we start solving examples, it will make more sense, hopefully. Okay, and similarly, if I have anything like this, it means A and B. The next one means A or B, because as I said, often instead of writing it in words, we'll use these symbols. Okay, so I think yeah, it's already 9:30, so we won't go for any more examples. But for Wednesday, uh, you definitely need to remember these symbols. Definitely will see examples for this, but I want you guys to already have this back of your mind. And okay, and I just want to to see up to example 14, okay? We'll start with example 15. So just go over up to examples 14 and see if you can generate any question from that. And I've already told, don't look at the solution first, look at the question, hide the solution, try to imagine what's going on there, try to find the result by yourself, then cross-check it uh, by just eyeballing the solution, okay? So go over the examples. If you have any question, even during the weekend, I think I'll be able to reply you within an hour or so. So shoot me an email if you find any question. And as I said, I'll post one really small homework for you guys during this weekend. And once I post it, I'll let you guys know. Okay. So have a great weekend, and I'll see you guys on Wednesday.
Thanks.
Thank you.
Take care.